Conditions for equilibrium. Thanks for watching this video and don't forget to like, subscribe to the channel and activate the notifications. It is very important to the continuity of this channel. When you learned the Newton's laws, probably your teacher said that an object is in equilibrium if the resultant force on the object is zero. This definition is adequate provided the object is a point mass, or all the forces act through the same point on the object that is not a point mass. However, we are now concerned with forces acting at different points on a body that is not a point mass. In this situation, even if the force is balanced, there may be a resultant moment. In other words, if a resultant force acts on an object, it will start to move off in the direction of the resultant force. If there is a resultant turning effect, it will start to rotate. To check that a body is in equilibrium under the action of forces, we need to check two things. That the resultant force is zero. This condition is a statement of translational equilibrium. If the sum of all forces acting on the body is zero, so the body is at rest or it is moving at constant velocity. The principle of moments must apply. This condition is a statement of rotational equilibrium. If the sum of all torques on the body is zero, so the body is not rotating. A box is balanced on a uniform plank of length 2 meters with a pivot 50 centimeters from one end, using a 20 kilograms mass placed at the end closest to the pivot. If the center of gravity of the box is 40 centimeters from the other end of the plank and the mass of the plank is 5 kilograms, calculate the weight of the box and the normal force of the pivot on the plank. If the box is in equilibrium, we must check the two conditions above. First, we apply the principle of moments, taking moments about the pivot. We now perform the calculations. The weight of the box is 66.8 newtons. For equilibrium, the resultant force acting on the system must be zero. The normal force upward of the pivot on the plank is equal and opposite to the total downward force acting on the plank. We now perform the calculations. The diagram shows a man of weight 600 newtons standing on a footbridge that consists of a uniform wooden plank just over 2 meters long of weight 200 newtons. Find the direction forces exerted on each end of the plank. The diagram shows the forces acting on the plank. For equilibrium, both the resultant force and the total moment must be zero. In calculations, we can always eliminate the turning effect of a force by taking moments about a point through which it acts. In this question, we will take moments about the point A. Take moments about the point A gives the reaction force S is 250 newtons. As all the forces act vertically and we know the net force is zero, we can write the reaction force R is 550 newtons.